Okay, starting with number 2, we're going to look at, this is a binomial, right? There's a term on the front and a term on the back. So we're looking at those two terms and we're asking ourselves, what goes into both 8 and 56 evenly? Okay. 8 goes into 8 and 8 goes into 56, right? Okay, and what else do these two terms have in common? They have an A. So that would be the GCF, the 8A. They both have an 8, a factor of 8, and they both have an A. Okay? And then what we have to do is leave what's left over. So if I pulled from this an 8 and an A from this first term, what's left? An X minus, if I pulled a factor of an 8 from the 56, what's left? No. Factor, not subtracting, factor. 8 times what is 56? 7. And then I pulled out the A, so there's nothing left besides that. It's the opposite of distributing. Because watch, if I were to distribute, 8A times X would give me 8AX. And 8A times negative 7 would give me negative 56A. It's the opposite of distributing. You'll get it. Yeah. Backwards distribution, yes. It's moving opposite. And you can always check yourself by distributing back in to see if you get the same term. Thanks. Okay, so number 3. Binomial. So let's look at the bases first, 35 and 40. What do they have in common? 5. Okay, what else do they all have in common?
A squared.
Okay, wait, how many A's do they all have in common? 2. This one has A squared, so that's 2 A's, or A squared. This one has A cubed, so it has A times A, but it's what they have in common, so you can only pull out what they have in common. They have 2 A's in common. Go with me?
Yes.
Okay, B's. This has a B cubed, this has a B squared. How many do they have in common? B squared. This has a C and this one has C squared, so what do they have in common? C. Just C. They don't both have a C squared. They just have, this has a C, this has a C squared. So we can only pull out one C. Okay, so we say what's left over. 5 times what is 35? 7. We pulled out the A squared, so we have no more A's. We pulled out a B squared, but it was a B cubed, so how many are left? 1 B. And we pulled out the C, so there's no C's left.
Wait, so why do you only have one?
There's only one there. If there's only one here, and there's 2 here, we can only pull out 1 because they only have 1 in common.
So then what happens to the B that we did?
There were 3, we only pulled out 2, so there's 1 left. So subtraction, remember? Just like when you multiply, you add the exponents. When you divide, you subtract the. This is what's happening right here. Okay, 5 times what is 40?
8.
Okay, we pulled out an A squared. Do we have any A's left? 1. We pulled out a B squared. Do we have any B's left?
Oh.
No. We pulled out a C. Do we have any C's left?
Yes, 1.
So again, you could distribute and check. 5 times 7, 35. A squared times no A squared is A squared. B squared times B, B cubed. C times no C's is C. And then 5 times 8, 40. A squared times A cubed. B squared times no other B's, B squared. C times C, C squared. See how we're checking ourselves? Okay, I know it seems like a lot, but you'll get used to it the more you do. Okay, let's keep going. Number 4. Okay, now we have a trinomial, so that means all 3 have to have something in common. 3, 9, and 36. What do all 3 have in common?
3.
3. How many x's does each one have in common?
1.
Just 1. It's the least amount that they all have. Okay, it's not the most amount, it's the least that they all have. Okay, this has a y squared, and a y, so what do they all have? 1 y. Okay? So 3 times what is 3? 1. Or just nothing. You could just write nothing because that means the same thing. Not 0, but just not write a number. X times what is x cubed? X squared. And then we already pulled out the y, so we're good with the y's. Minus 3 times what is 9? 3. We already pulled out the x. We pulled out 1 y, so what else do we need to write? Y. Y times y is y squared. Okay. Plus 3 times what would be 36? 12, and we already pulled out the xy, so we're done. Okay, I want you guys to try number 5 on your own. Try number 5 on your own. Okay, so what does these 14, 18 have in common? 2. And is that it? An x. They both have an x, and they both have 1 z. Okay, now whatever's left over after we pull out those factors, we leave in our parentheses. 2 times what is 14? 7. We already pulled out the x. We already pulled out the z. So we don't write anything else with our 7. Minus 2 times what is 18? 9. We pulled out the x. We pulled out one of the z's, so we would need to write one more z. And that's it. Okay. Any questions? Yes. Okay. Okay, so on number 6, it looks like a lot, but just break it down. 28, 21, and 14. What number you know goes into all that? 7. Okay, then we just see A's, B's, and C's. We need what they have in common, the least number that they all have. A squared, and A. Just one A. B squared, B, and B. So they all have one B. C squared, and C. They have one C. Okay? Parentheses, what's left over is what we keep on the inside. So 28 divided by 7, or 7 times what is 28? 4. I said 2 different things. 28 divided by 7, or you could say 7 times what is 28? Oh, no, not there yet. Okay, we pulled out an A, so how many do we have left? 1 A. We pulled out a B from the B squared, we have 1 left. We pulled out a C from the C squared, we have 1 left. Plus 21 divided by 7. So basically we're dividing. A squared divided by A. B divided by B, no B's. C squared divided by C, minus 14 divided by 7. And then A divided by A, B divided by B, C divided by C. You got them all. And that's it. You getting the hang of it now? Yeah. Kind of seems a little crazy at first, but not too bad. Okay, number 7. 6x squared y minus 5x plus 7y. Yeah, 6, 5, and 7. Well, 7's prime and 5 is prime. And the only thing that goes into 6 is 2 and 3 besides 1 in itself. So really, this whole thing, it has nothing in common.
That's it.
So this is already factored. You can either write already factored, or you can write, you can just rewrite it, because this is its factored self. You can't factor this. There's nothing in common. They don't have numbers in common, and they don't have variables in common. These front 2 have x's, but the last one doesn't. They all have to have it for you to be able to pull it out. And then the front and the back have a y, but the middle term doesn't. So there's nothing for us to pull out except for a 1. So this is already factored. Okay? Oh, already factored. Maybe I should put the ed on the end, right? Okay. So 8 and 9, 10, 11, these look a little different. Why? They're all variables. Well, except for the 2's here. One other thing you haven't seen yet. There's 4 terms now. Okay. That's okay. We're going to treat it the same. This is a polynomial because there's no actual word for 4 terms. But 4 terms are treated a little bit differently because if you don't see anything, do you see anything in common with all of them? No. What do they all have? No, they don't. That one doesn't have an X, and that one doesn't have an X. They don't all. No, they don't all have K's. Nothing.
They all add up.
No, they don't. There aren't like terms. You can't add them. Okay. The point is, there is no like term. There is no factor here. However, if it's 4 terms, here's what you're going to do. This is important. This is called grouping. You split the front 2 and the back 2 terms. You're grouping. You're grouping the front and you're grouping the back. So right now, I want you to cover up these 2 terms and just look at the front 2. What do the front 2 have in common? R. So we're going to pull out an R, and we're going to leave what's left over inside. X plus 2y. Okay, that's called grouping. We're grouping the front. We factored the front 2. Plus, now we're going to group the back 2 terms. What do kx and 2ky have in common? They have a k. So pull out the k. And what's left over? X plus 2y. Ding, 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 ding. You should notice something. You should notice the parentheses match. This is a good thing. When the parentheses match, yes, if you're doing grouping, your parentheses should always match. If they don't match, then something's weird, okay? So when they match, that's part of your answer. X plus 2y is what is matching, right? You only write it once, okay? And then the rest of it is what's left over. The R and the K, the plus K. That's your answer. Okay? So the X plus 2y is your binomial answer, and your other binomial answer will be the R plus the K, what's outside of the parentheses. Okay? Yes, because it's a we'll be factoring trinomials. That'll be the most common thing you'll see. We'll start that tomorrow. And when you factor trinomials, you factor them into 2 binomials. And that's what this is, 2 binomials. And they'll be in parentheses. Okay? I'm sorry? Hold on, let me pause this. Okay, number 9 is already factored for you because look, you've got the 2 parentheses, and don't they already match?
Yeah.
Right? A squared plus b squared, a squared plus b squared, they already match, right? So that's part of your answer. A squared plus b squared is your first binomial. And then what's on the outside? X squared. There is a plus 1. Thank you. Where is it?
They didn't have to write
It's right there. You can't leave that off. The x squared and then the plus 1 is your second binomial. So that was already grouped for you. That one is nice. Right here. I'm sorry. Number 10. We're going to group 4 terms. They don't all have anything in common. Split. Look at the front 2 terms. 6n cubed plus 8n squared. What do 6 and 8 have in common? 6 and 8? 2.
Oh.
And what do n cubed and n squared have in common? N squared. They both have 2 n's. Okay, so now what's left over? 6 divided by 2, 3. N cubed divided by n squared. N plus 8 divided by 2, 4. And then n squared divided by n, we don't have any more n's. Okay, that's the front. Now the back. Plus, do 3 and 4 have anything in common? Except for 1. And do they have any n's in common?
No.
So the only thing they have in common is, and you want to write that. You got to write the 1. That's the only thing they have in common is the 1. And then basically what's left over? 3n plus 4, the whole thing, right? Because we didn't pull anything out. Do our parentheses match? Yes, this is a good thing. So we rewrite that. 3n plus 4. Your parentheses match. And then what's left over goes in your other parentheses. 2n squared plus 1. Very good. Okay, let's try number 11. Actually, I want you to try number 11 on your own. First thing, though, I want you to look at is, do you see how there's an A here and there's not one here? But there's a 3, a 2. We need to put these in the right order. They need to be in descending order from the exponent. So there's 4a cubed minus 2a squared. What should go next? Plus 12a minus 6. If you don't do that, then your parentheses will be like flipped around. So you want to make sure they're in the right order. So now I want you to factor this guy right here. Split it and group. What? I start my video. Okay, so what do the front two terms have in common?
2.
And a squared. So we have 2a minus 1. You cannot just put 2a. Okay, we pulled out the 2 and the a squared, but there's still a negative sign. So we got to have the negative, what number? 1. Because 2a squared times negative 1 is negative 2a squared. You've got to have that minus 1. Okay? And what did the 12a and the 6 have in common? 6. So we pulled out 12 divided by 6 is 2, a, and then minus 1. Right? Yes. So since they match, 2a minus 1 is what they match. And then 2a squared plus 6. Okay, here's where the GCF comes in. 2a squared and the 6, something can be factored out of those. What do those both have in common? A 2. And when you pull out a 2, you get a squared plus 3. And then you rewrite the 2a minus 1. So really, this is the most complete answer.
Would that be on the test?
Maybe.
What? It would be like that and not like the first one?
Well, this isn't completely factored because there is a GCF right in here. They both have something in common.
So it'd be 2 plus 1. Oh, okay.
So you pull out the 2 and you would rewrite this as a squared plus 3. So that would be your final answer. Okay. All right, let's look at number 12. It's not written in the right order, is it?
No.
So we got to rewrite it. Which one should go first?
12C.
12c cubed minus 9c squared plus 20c minus 15. Do they all have anything in common? No, these have 3s, these have 5s. So we need to split. What do 12 and 9 have in common? 3. And how many c's? 2. Okay, 12 divided by 3. 4. C's cubed divided by c. C. And minus 9 divided by 3 is 3. And I already pulled out the c squared. Okay, so whatever we pull out here needs to match this. So this can be a help of what you can pull out. 20 divided by what is 4? So yeah, we're going to have to pull out a 5. Our GCF needs to be a 5. Is there anything else besides a 5 we can pull out? No. So 20 divided by 5 is 4, and then C minus 15 divided by 5 is
3.
Okay, do they match? Yes, so we're good. If they match, we're good. If they don't match, something's wrong. So 4C minus 3 is the front parenthesis, and what's our second parenthesis?
3C squared plus 5.
3C squared plus 5. Ding ding. Okay, last one. Do we need to rewrite it? No. Okay, ask yourself, do they all have something in common? Yes. What do they have in common? An H and a 3. They're all divisible by 3. 21, 72, 15, and 8 are all divisible by 3. So let's go ahead and pull that out on the front end. And we have to pull out the H. H cubed. They don't all have 3 in common. They only have 1. This one has 1, so we can only pull out 1. Okay, so 3 times 21 is 7. h cubed plus, what's 72 divided by 3? Thank you. 24h squared minus 5h minus 6. Okay. Are we done?
No.
No, we pulled out the GCF, but we still need to split. So the difference between 11 and 13 is there really isn't a difference. The 11, we just factored the GCF out at the end, and number 13, I'm factoring it out at the beginning. You can do it either way. Doesn't matter if you factor it out at the beginning or out at the end. Either way, you're still going to have to group. Split. What does the 7h cubed and the 24h squared have in common? Okay, so for right now, just leave your GCF that we pulled out. Leave that alone. Just leave it for now, okay? We're going to come back to that at the end. Okay, what do just these two terms have in common?
7.
No, not a 7, right?
1.
Okay, just an h. H squared. Sorry. Did I do something wrong? And then, oh, they won't match though, will they? Okay, so we're kind of done. Because if we factor, I mean, maybe there's a typo here. Because if we pulled stuff out here and pulled stuff out here, they won't match, will they?
Was that it?
So you can just leave it like, yeah, you weren't going to see this. You're not going to see anything like this.
Yeah.
Except for, you'll have to know how to pull up the GCF, but it needs to be able to group. All right, let's move on. I don't think so. If you do, then we'll talk about it tomorrow. Okay, what's our other questions? Okay, so this is the big area minus the small area, right? We got to find the area of the big rectangle. So we need to find what is the distance of this whole length. Well, this from here to here is y, and then this from here to here is 3 and 3. So the whole length would be 6, not y, 6 plus y. Yeah, because it's y and then your 2, 3. So I would even write y plus 6. Okay, and the height, okay, you have your x all the way across here, and this is 3, and this is 3, so that would be x plus 6. 3 and 3 is 6. So to find the area of the big, you would just multiply. Yeah. So this is the distributing part. This is the opposite of what we are doing, factoring. Distributing and factoring are opposites of each other. Holy, I'm getting so many emails. Okay, y times x is just yx or xy. Y times 6 is 6y. And then 6 times x is 6x, and 6 times 6 is 36. And can you combine anything? No. So that's the area of the big. Okay, now we gotta find the area of the small, which is actually a lot easier because it's just the length is y and the width is x. So the area of the small is just xy or yx. I usually write it alphabetical order. Okay, and then we're gonna subtract. So subtract yx from, I'm sorry, xy from xy plus 6y plus 6x plus 36. So really, that just cancels, right? And what do we have left?
6y plus 6x plus 32.
Plus 36. But it also asks to write it in factored form. So we have to ask ourselves, is there anything we can factor out of this? A 6. Wait. No. Not a 6. Because 6 doesn't go into 32 evenly. I don't know why I wrote 36. Oh, because you said 32, I wrote 32. Sorry. Yes, a 6. So really our answer is 6 y plus x plus 6. Okay. we're going to go ahead and stop for today. We're not going to have time to finish these. That is okay.